Welcome to Summarize Science. Have you ever asked an AI a question about an image and it gets it completely wrong, even though the answer is staring you right in the face? It's a common problem with today's powerful AI, and researchers have been trying to figure out exactly why it happens. The big question is the AI simply blind to the evidence, or is something more complicated going on? By looking inside the AI's brain, its internal attention layers, they discovered something fascinating. In the early layers, the AI mostly focuses on the text of your question, just like you would. But in the deeper layers, it shifts its focus to the image, creating an internal spotlight that zeroes in on the most relevant visual evidence. But here's the bizarre part. Even when the AI's internal spotlight was aimed at the correct evidence, it would often provide the wrong answer. The paper calls this the seeing but not believing phenomenon. For example, here the AI correctly looks at a sign that clearly says NGS, but its final answer is Logitech. It seems the AI's language part sometimes overrules what its vision part sees, falling back on common word associations from its training data. Based on this insight, the researchers developed a simple but brilliant solution called Visual Evidence Augmentation, or VA. It's an inference-time method, meaning it requires no expensive retraining of the AI model. First, they do a quick, single-token pass to see where the AI's internal spotlight is pointing in the image. Then, they use that information to create a new version of the image where that important region is highlighted and the rest is slightly darkened. Finally, they feed this new, visually enhanced image back to the AI and ask the question again. The results were impressive. This simple trick of making the visual evidence more obvious consistently improved the AI's accuracy across a whole family of different models. As you can see in this table, the performance gains for the VA method are significant compared to the base models. It effectively helps bridge the gap between what the AI sees and what it believes, leading to more factually correct answers. So, let's quickly recap what this all means. First, we've learned that modern AIs often correctly perceive visual evidence even when they get the answer wrong. The failure isn't in perception, but in reasoning, where the model's language biases can cause it to ignore what it's seeing. And most importantly, we can guide the AI to the correct answer by simply using its own internal focus to highlight what's important. This is a huge step toward making AI more reliable and trustworthy. In the future, this could lead to AIs that can actively decide to zoom in or enhance parts of an image on their own to solve even more complex problems.